Hello students, welcome to AC Engineering. In this video, we are going to see RH Criterion Case 2 problem. So here before we posted concepts of stability, then second video RH Criterion Case 1 related problem. So you refer the first two videos, then only this video would be useful for you to make an understanding. So the case 2 is with a row of all zeros. First I will explain you the things with a row of all zeros. Then it is easier for you to understand. See here in case 2, these polynomials can be analyzed by either of the two methods. First I will explain you the procedure for solving the case 2 problem in method 1. So in method 1, first determine the axillary polynomial A of s, then differentiate this auxiliary polynomial with respect to s and get dA of s by ds. Then in the third step, the row of zeros is replaced with coefficient of d of as by ds. Then continue the same as like that of an usual manner what we did in an case 1 and construct an array, and from this array we interpret following 2 points. Listen the first point carefully. If there are sign changes in the first column of the Routh array, then the system is unstable. The number of roots lying on the right half of the S-plane is equal to the number of sign changes. Then the number of roots on the imaginary axis can be estimated from the roots of axillary polynomial. The remaining roots are lying on the left half of S-plane. Then carefully note the second point in your mind. If there are no sign change in the first column of the Routh array, then all zeros row indicate the existence of purely imaginary roots and the system is marginally stable. The roots of the axillary equation lies on the imaginary axis, then the remaining roots lies on the left half of a S-plane. So before proceeding the problem, first note down the characteristics equation, find the order of an equation, how many number of an order, that many number of roots. If the system is said to be stable when all the roots are in the left half of an S-plane. If the roots are in the right half of the S-plane, then the system may unstable or marginally stable. We'll pass on to the problem. We'll see RH stability criterion related problem with case number 2, method 1. Note down the problem. As per the given problem, construct Routh array and determine stability of the system, and its characteristics equation is given as 8 bar S bar 6 plus 2 s power 5 plus 8 s power 4 plus 12 s cube plus 20 s square plus 16s plus 16 equal to 0. Also, we are asked to determine the number of roots lying on the right half of S plane and left half of an X plane and an imaginary axis. Let us get into the solution side. So, the characteristics equation given is have an order of 6. The highest power of S value in an equation is order. The highest power of S. So, it has sixth order equation has 6 roots. So, now our objective is to find the stability of the system, whether the system should be stable or unstable or marginally stable. Then how, if it is unstable, obviously all the roots are lies on the left half of the S plane. If not, we will find out how many number of roots are in the right half of an S plane. For an unstable system, it is very easy. For marginally stable system, we have partial roots on the left half of an S plane and partial roots on right half of an S plane. We need to determine the same. Now, construct an array. So, we can start it with an 8 power 6. So, where we can write the first row all coefficient of even powers of S. So, 1, here S power 4 coefficient 8, then S square coefficient 20, then S power 0 coefficient 16, which frames row number 1. Then all the add numbers constitute the second row. Here is S power 5 coefficient 2, so here 2, S power 3 coefficient 12, here 12, S power 1 coefficient 16, here 16, which constitute row 2. So, for our ease of convenience to proceed further steps, we reduce the reduce the S power 5 second row for simplification of an calculation. See here 2, 12, 16. So, divided by 2, which gives the values of so after simplifying, we will get the equations. First row as it is, then the second row should be reduced as by dividing second row by 2. So, 1, 6, 1, 1, 6, here 1, 6, here 8. So, roll off and we will get first row as it is, second row as it is. Then, as per the procedures what we followed in a case 1, need to follow here also to get S3. How to find S3? Consider here 1 into 6 minus 6 into 1 divided by 1. See here, here 1 into 8, 6 into 1 divided by 1, which gives the value of 2. Then for the next case we need to consider this column and this column. 1 into 20, 8 into 1 divided by 1. 1 into 20, 8 into 1 divided by 1 gives 12. Then for next calculation, consider first column and fourth column. 1 into 16, 0 into 1 divided by 1 gives you 16, means 2, 12, 16. Again divide, for an simplification, divided by 2 gives 1, 6, 8, which forms S power 4. So here S power form 4, row formed as 1, 6, 8. 1, 6, 8. Then go with an next row, means S power 3 row. Consider here 1 into 6, here 1 into 6, 6 into 1 divided by 1. Here the calculations are given, so gives you 0. Then consider this column and this column. 1 into 8, 8 into 1 gives 0. So the entire row of S power 3 becomes 0, which comes under case 2. So what is the procedure in case 2? In case 2, if a 0 comes, then we need to frame an auxiliary equation and differentiate it with respect to S and proceed on further cases. Now the auxiliary equation, write an auxiliary equation. This is a case where we get an 0th row. So previous row, it's an S power 4 row, means all the terms are even par S power value coefficients. So it is S power 4, then this one is 6S square and this one is 8 S power 0, means constant value S. Similarly here we write an auxiliary equation from this S power 4, 6S square plus 8 equal to 0. Now differentiate it with respect to S. So it becomes, here becomes 4S cube plus 12S. So here S cube value becomes 412. So for a case of convenience, 412 we can divide it by 4 gives 1, 3. So S power 3 equation, auxiliary equation, we found an values for S power 3 row as 1, 3. Now try to find S square row value. So what to consider? We need to consider this value and this value, means 1 into 6, then 3 into 1 divided by 1. See here the values given as 3, here the values given as 3 and 8 S square. Now substitute S square value here, then try to construct S power 1 value. Here 3 into 3 and minus 8 divided by 3. The calculations are given here for S power 1 as 3 into 3 minus 8 into 1 by 3 gives you the value of 0.33. So you substitute the value here over S power 1 as 0.33. Now construct S power 0. How to find S bar 0? 0.33 into 8, 0 minus 0 into 3. So it gives a value. Refer here the calculations as 0.33 into 8 minus 0 into 3 by 0.33. 0.33 get cancelled. S bar 0 value 8 only. So substitute here as 8. Now try to analyze the first row of a Routh array and give the interpretation. So while doing an observation, we found that the first column of a Routh array is observed no sign change, only positive values. Now the row with 0 indicates possibility of imaginary axis. If there is any sign change, then the system should be the unstable. There is no sign change, but there should be an cause of an 0 row, which indicates that the system has some possibility for imaginary axis. Hence, the system is marginally stable. Now, how to find the roots of this equation, roots of the system? From this, the auxiliary polynomial what we have written is found here. So the auxiliary equation found here as s power 4 plus 6s square plus 8. Consider this equation where we have an 0 value. Let s square equal to x for our convenience. So this equation becomes s square equal to x. So this equation becomes x square plus 6x plus 8 here given. So we made it as a quadratic equation. Now we know the procedure to find the roots of the quadratic equation, which is equal to minus b plus or minus root of b square minus 4ac divided by 2a. From this, we can find the roots are, we can find this roots of this quadratic equation is minus 6 plus or minus root of 6 square minus 4 into 8 into 1. 8 into 1 divided by 2 into 1. So the roots given are minus 3 plus or minus 1, means it has either possibility of minus 2 or minus 4. Now we can write the roots of the auxiliary polynomial. What we consider? We consider x square, x is equal to s square. Simplify this equation to make it as an quadratic equation format. We consider like this. Then now the s is plus or minus root of x. We already have two roots, minus 2 or minus 4. So it is plus or minus square root of minus 2 and plus or minus square root of minus 4. So the roots are plus j root 2 or minus j root 2 plus j2 minus j2. So as far as our discussion concerned, we know that we have roots of auxiliary polynomials are roots of characteristics equation. Here we have 6 roots. 4 roots are lying on imaginary axis and the remaining 2 roots are lying on the left half of the S-plane. So we can't able to say the system is either a stable or an unstable system. Instead, it is marginally stable system. 4 roots are lying on imaginary axis and the 2 roots are lying on left half of an S-plane. So it is lying on imaginary axis, that's why it is marginally stable. If it is in the right half of the S-plane, the total system should be unstable. So these are all our findings from the given problem. Well students, hope you can understand. You go through the video once or twice, then you can easily understand the things. Now the given problem is from Routh Stability Criterion Case 2 Method 1. We'll see rest of the cases in the next video. Thank you students. Thanks for your support.